to understand abstract data types or ADT, it is important to understand the data type first, and before that you should also understand what is data. What is data? We have discussed in our earlier session about data structure, introduction to data structure, and we have found that data is nothing but facts and figures, raw facts and figures, which is processed by a computer or computing system, and then it produces information. This is the basic understanding of data. Our main goal is to process the data. Without data, there is no point writing programs. It is the concern of the programmer. It is the concern of the programmer how to process data and how to arrange it inside the main memory, and that management of data inside main memory basically known as data structures. And when we talk about data, data is, again, there are various types of data, and that's why we have the term data types. Data types. And to understand what is data types, let us see this definition. Data type is nothing but a kind of data items as defined by the values it can take, and they are also equipped with certain operations that can be applied on the values of that data type, and the resultant value of the operation is also belong to same data types. Assume that some data, for example, marks obtained by students in physics or mathematics. Definitely we will have the marks in the range of 0 to 100, right? And including sometimes some fraction like say 70.5. If I consider the name of students as data, then the nature of data will be different than the nature of the physics marks. There also the roll number. If I consider roll number, only the roll number without any alphanumeric characters, then what we can tell that this will be definitely, it cannot be 0. It will starting from the maximum number of students in the class. So each of these data that we collect in order to process has different characteristics. So based on that characteristics, in C programming or any other programming languages, the data is divided into mainly 3 different types. These are called fundamental or built-in data types. And first one is called integer, which is a positive and negative counting numbers as well as zeros. This is considered as integer numbers. And second fundamental types of data is called floating point numbers. This data type uses a formulaic representation of real numbers as an approximation. And next type of data that we have is this a character data type, which represents an alphanumeric character, and it is an integral data type, meaning the value is stored as an integer. You know the concept of ASCII values, ASCII values of characters. So when it is stored in the memory, basically it is stored as integers. These are basic data types used in programming language like C or any other such programming languages. And apart from that, there is one more data type which we use in our programming, that is called Boolean data types. And this Boolean data type, it has 2 possible values, either true or false, and this is called the truth value. These are truth values of any Boolean expression or Boolean operation. And these 4 categories of data, it is inbuilt, and that is why mostly it is known as fundamental data types. And also, whenever we talk about a data type, either it may be integer, character, or floating point number, or Boolean, then with every data set, there are certain operations associated with that data set. For example, with integer data type, we have the operation plus, we have operation minus, we have operation division, multiplication, so on, so forth. Similarly, in case of floating point number also, we have the set of operations associated like this, same as the integer. And in case of character, we also have certain operations. In case of Boolean, we can perform the operations like AND, we can perform the operation OR, NOT. These are all operations that can be carried out on a data set of the type Boolean. So in short, what we can conclude that for every data set that is defined by the programming language, this is not only about the data set, but apart from the types of data, every data type also defines a set of operations, and this set of operations to be performed on the similar data types. For example, if I want to perform the plus operation, and we should have two operators, two operands, 6 plus 7, both should be of the type integer, and it will evaluate another data which also belongs to integer. So it says that if any operation is defined with respect to a certain data types, then it must take data from the same data set, and it also produce another new data which is also belongs to the same data set. It means that generally, if I add two floating point numbers, say 6.5 plus 9.5, it does not produce any integer as per the norms defined with the data set. However, if I want to do 6.5 plus 9.5, which will give you 16.0, we can say that 16.0 is an integer, but it's not necessarily true, because 16 is an integer, 16.0 is not an integer. That is the way the data set is defined in the program. Similarly, for all other data set, the same thing is applied, and it is said that for every data set, we have a set of operations which is defined in terms of that data set only. Most of the time, these fundamental data sets or fundamental data types are not sufficient to meet our requirement. For example, I want to store the information about a student. I want to store information about a student's information. In that case, the information about the student is actually comes with a roll number and name, and where roll number is of the type integer and name is of the type character. So if I want to group this together, then we can see that if you want to group this, I mean, one student should have by default two characteristics, one is roll number and another is name. In that case, fundamental data types not solve our need. Okay, in that case, what we need to do, so in order to solve that problem, the programming language, generally the C programming language, has the construct which is known as a structure, where a structure, we define a structure like struct, say student, within the block, this is the name of the structure, then we will write a integer roll number and character name, it's an array of 10 characters, say. So now it becomes a group, and this group can be considered as a data type, and this type of data type is called user-defined data type. Mainly the fundamental data types that we have, fundamental data type cannot meet all the requirements, cannot meet all the requirement of a programmer. That is why we have formulated the concept of user-defined data types, and these user-defined data types combines fundamental data types and derive a new data type as per the the need of the problem. For example, we have seen that student, if we want to keep the record of a student, then we use the concept of structure, struct student, where we define two data types. One is integer, roll number, or say float, physics marks, like this. I want to store only the physics marks along the name of the student, so it will keep the roll number 1, then the physics marks is 70, roll number 2, physics marks is 70. That way this is roll number, this is marks obtained in physics. So now this is a group, and this group is called structure, and this structure comprises of two fundamental data types, but they are defined as a single group, and this single group is known as user defined data type, UDT, user defined data types. And not only that, if it is only user defined data type, and that can be considered as, suppose that I declare one variable integer x. Similarly, we can also do struct student s1. We can do this. This is a variable that holds integer data type, which is fundamental, and this s1 is a variable which stores student data type, and this is user defined data types. So as it is said that it is not sufficient to define only the data types, it is also important to define a set of operations. A set of operations need to be defined with the data type. So here student is the user defined data type. However, this will be completed only when we define some certain operations on the data set. That means if S1 is the data, S2 is the data which is of the student type, and then we should be able to perform certain operations. If we can somehow define all the operations, like say one operation is get data, for example, get student. If I say get student, it is nothing but a function, and which that function will be used to get the information. It will read the roll number and the name from the keyboard, or user will type the keyboard, and that content will be stored in the variables of roll number and the name. Okay, so if we define this function associated with the student data type, then that can be considered as a valid operation to be carried out. Valid operation. But when we will call this function, we must have to be careful that when we write get data, let us within bracket we have to write s1. It indicates that it will get the data for s1. So this becomes the operand, and this becomes the operator. For example, if I say not of x, where x is the Boolean operator, Boolean variable, then it will alter the truth value of this variable x. So similarly here also, this get data will be performed on the data type s1 or student, and which will get data from the keyboard and will be stored in the variables declared for the student data type, right? That is called, if we do that, then in real sense it will be a data type, or in a better way you can say this will be the user defined data type in your program. Our main objective is to discuss about abstract data type, and I have said that a user defined data type is a data type that is derived from existing fundamental data types, and UDTs can be extended to create customized data types and may be used as a built-in types. That we have seen when we create the student data types, we can use it as a fundamental or built-in data type. But however, we didn't tell you what is abstract data type. User defined data type, after we designed a user-defined data type. Now let us understand what is the meaning of abstract. One very interesting definition of abstract with respect to the data types. It says that abstract means to separate something from something else. This is very interesting definition as far as the abstract data types is concerned. It is telling that you have to separate from something. Then what need to be separated? Basically, I told you that any data types is considered as a complete data type only when it comes with the operations supported on that data set, right? In that case, if I want to define a define an operation get student, I want to define a operation get student on the data set that belongs to variable on the data set student. This variable belongs to struct student, right? In that case, what I need to do, it is, since it is a function, right? If it is a function, then I must have to have some prototype. Void get student, then this will take struct student s1 like this, and we need to define the statements here. So this is the operation defined with respect to the student data type. And when we define it, there are two different parts here. One person who will define this function and it will keep it inside the library, and the programmer which actually using the data type s1, simply he will write the statement get student s1. Now the student, I mean if the programmer use this statement get student s1, then it will get the prompt, or it will get the interface in order to enter data for roll number and enter data for physics marks. So however, the programmer who is using this student get student function will not be aware how it is defined. I mean, what type of, is he using scanf statement or is he using getS statement? This programmer who is actually using the function will not be aware about this implementation. If we do that, then this is called that implementation detail of the function get student. Implementation detail of the get student function or get student operation is hidden to the programmer. In that case, what we will do, hidden to the programmer. In that case, we are assuming that the programmer who make use of the get student function is not actually designing this operation on the student. Simply he is using it. If we do that, that means we are hiding something, or we are separating. We are actually separating the implementation detail of the function from the using details. Here I am using this function, and here I am implementing this function. So implementation details are not explicitly exposed to the user of the operation. That's why this is called abstract data type. In short, again, if I conclude, then an abstract data type is basically user-defined data type. And this user-defined data type also comprises certain operations. It comprises of certain operations defined on that particular user-defined data type. However, since it is abstract, that is why implementation details of various operations, various operations are hidden from the user of the data set or data type, user of the data type. If it happens, if you preserve this requirement, then that becomes a abstract data type. Okay, and this is similar, then if it is defined as an abstract data type, then that can be considered, or that can be treated or used as a fundamental data type, because whenever I do this operation 6 plus 5, I simply get 11, but I do not know internally how computer executes this 6 plus 5. If you see the ALU, structure of the ALU like this, structure of the ALU, if I consider the structure of the ALU, it has 1, 2 input lines, 1 output lines. Data will go here, 6 will be here, 5 will be here, and 11 will come out through this output line. So we do not know how it is performing. It may be used some hardwired control, it may be used micro programming control. So anyways, I'm interested only the result, and I do not know the implementation details of this plus operation. So that is why it is called this fundamental data types itself is an abstract data type for us. Similarly, we are doing the same thing in case of user-defined data type, so as to make the feel of the design data set or data type as fundamental data types or built-in data types. Okay, and next we will see with the help of a program how that can be achieved in programming. So what I am doing here to understand what is user-defined data type, I am writing a program. I am considering a problem of implementation or implementing. We want to define a complex number where the complex number is basically, it has a real part plus some imaginary part, say 5i or i5, where 3 is the real part and 5 is the imaginary part of the number, and this is called a complex number. And I mean, there is no fundamental data types of the type complex number. That's why we need a data type which is called the user-defined data type, which is supposed to be defined as, with the help of a structure. Let us suppose this struct complex number, say struct complex number, and in the complex number we have two components. One is, let us say this is the end of the complex number structure, and it has two parts, integer real, and next one is float, or say this is also okay, float imaginary. This is the two parts of the complex number, right? Okay, let me log this. This is not important, we'll come to that later on. And this is the complex number. Okay, so let me close this here, and these are two numbers. Now what I will do, I will define three variables, c11, c12, c13. These are struct complex, but before that, what I am using, I will use one function which is called the get data, get number. I'm defining one get number which will take, get number means it will read the complex number, and it will take one struct complex number, say c1, and it will also return one struct complex number. Also, I want to have one more function which is called add numbers, which will take two parameters. One is the struct complex number C1 and one more complex number C2, right? C2. These are the function prototypes defined for this program, and also this one will return another struct complex number, right? These are two function and these are two function prototypes. I can also write one function which is print. I will see the values of print complex number or print numbers or print number, which will take one struct complex number, and let us say it will take C as a parameter, and these are function prototype, and this will return nothing. So I'll write as void. I'll write this one as a void. By doing this, what I want to say is this okay? Yeah, it's okay. So what I want to do, these are considered, these three, these are, let us suppose that these are all operations performed, to be performed, operation defined on the data set or data type complex number. Now, without loss of generality, we can assume that, and these are the functions defined, right? Functions considered to be closed. I mean, there is a term that is called closed to a group of data type, right? So this is the end of those operations. Now these are function prototypes. We must have to define this function, and let me define the function. The first function is struct complex, this one control C, and this one control V. What I will do here, but the problem get number is C1, and there is a small problem in this function. I will show you what is the problem. First of all, I will define one complex, because I need to return that value, complex number temp, temp say. Then I will write down temp dot real is equals to temp dot imaginary equals to, however, here what I need to send, it's not complex number. Instead of that, I need integer x float y. So these two values will be passed to this function. That is why here also the same thing will happen. It's not struct complex C1. I will get the number. I can write scanf statement as well, but I'll not write that. Integer x float y, and if I go here, real part will be complex number, real part will be x, and imaginary part will be y, and I will write down, here return urn, return temp, temp, okay, return temp. But here complex number, why it is complex number temp? Is there any problem? Okay, anyways, let me check. Okay, struct tag is required. Struct that can be solved using some type def, but I'm not going to use that. So one function is defined. So if I do this, then let me define directly the print number function. After that, print number, this function need to be defined. Let me define this function here. Okay, so this one, I will close this function here. Then I will write down, so this complex C is coming, so print f. If I write simply print f, and I write here the number is like this. Okay, so in this one, let me first close this too and execute the program only with this. Let's do this. If I execute, is everything fine? So what it will do, it will get 2 3. So the number should be printed as 2 plus 0.3i. Let us say this is not 3 point. Okay, let it be, no problem. I have one more function. This is working. Let me see how this add number works. Let me define this add number function. Add number function, this is the prototype. I will go to the end of this. Here I will write, defined one temporary complex number, say temp, then I will write temp dot real is equals to, I will also write temp dot imaginary, and this one equals to c1 dot real plus c2 dot real. It will add both the real component and it will add c1 dot imaginary plus c2 dot imaginary, right? So if it is the case, then what I will do, I will return temp. Okay, so this real part will be both the real part of both the complex numbers c1 and c2 will be added, and then it will form the temp, and temp will be returned. On the other hand, what I will do, I'll take one more variable c12, and I will call the function add numbers, which will take c1 and c2, and it will add these two numbers and it will give the result in c13. So if I execute this code, I think no issue here so far. The first number is 2 3, second one is 2 4. It should give 5 plus 7i. So let me execute this code. It's giving 5 plus 7i. Okay, let me once again understand this program properly. Our objective is to see one user-defined data type to demonstrate the use of user-defined data type. So for that, what I did, I declared one structure, and that structure actually represents the complex number. This complex number will have two different components, real and imaginary. I am defining few operations. The first operation is get number. Of course, it's not like normal plus minus, but these are operations that can be considered as operations on it. And then add numbers and print numbers. These three operations I have defined with respect to this data type, user-defined data type. Then simply I am calling these functions get number for c11, c12, and then I'm adding two numbers, sending the result in c13, and I'm printing the value of c13. And I found that this is working fine, right? There is no problem. It's working fine, and it can be considered as the complex number. This complex number is actually a user-defined data types, but is it abstract user-defined data type or is it abstract data type? Change the structure of this code to this one. And this here I am defining some complex numbers, struct complex numbers c11, c12, c13. And also I am using the function get number, and add number, then print number, right? So these functions in the program, can you see the implementation details of get number? Using the functions or operations, but I do not know what is happening. Whatever we have seen with all implementation detail, it's not available now in this ADT. What I did, I have transferred all the implementation detail into some another file which is known as document h file. Okay, and this h file, all the definitions are stored in the .header file. If you give .h file, then immediately the colors are coming. So this is the syntax used by this compiler, I mean this editor actually. So this is considered as a program that uses a abstract data type. I do not know what is happening in get number, that I'm calling this get number with respect to the complex number. So I do not know the implementation detail. That becomes the abstract data type, because it is abstract because the implementation detail of all the operations are being hidden. But if I execute, the same thing will happen as the previous one. The same thing, it will give you 5 plus 7i, because 2 plus 3 is 5, 3 plus 4 is 7, and all other things are in the background is doing somewhere else, and that is the header file. So this is nothing but abstract data type, right? And for that you need to know how to define. This is called a header file, and this is user defined header file. User defined header file, and normally it is denoted not within square brackets, it is given within double quotation. It indicates that it resides in the current directory. So what is my directory right now? This is the code directory. This, the name of the directory is the code directory. This is located in my home, my home, user home, and then this is the subdirectory, and this is one more subdirectory level inside it. So if I see all the files here, then these all files are there. ls minus lh document.h. If I see this, it's a file of 875 bytes. This is 875 bytes file, and that file I am using as a header file, and all the definitions are stored in that header file. And while it is using, that will refer to that, and I will feel as a programmer built-in data types, not user-defined data type. It will feel as if I'm using one built-in or fundamental data types. That can be make a bit more simple. By for easier interpretation, we can do one more thing, and that will also look like that we are using as one fundamental data types or built-in data types. Let us this data type, user-defined data type struct complex, we have given a new name using the type def, the complex n, right? Complex n is the struct complex number is equals to the same as this complex n. This is because of the statement I have given here as type def, right? This one, complex n. So instead of writing every time struct complex number, let me remove it and let's write down as complex n. Here also the same thing, instead of struct complex number, we will write it as complex n, and everywhere we can remove it and we can put it complex n, right? These two parameters, complex n, exactly it means the same what is being done by struct complex number, and that is done with the help of this type def. So it will look more like this struct complex number is a fundamental data types or built-in data types, and since we have used also the various functions in order to implement operations, and this implementation detail is hidden, and that we put in a header file that we have seen in our program. So that will make things very easier, and that will make things a bit more close to the built-in data type. And that type def is certainly help to interpret user data type as a built-in data type.